The tractor. The tractor is the power unit that every other machine on this list depends on. It delivers three things: draft power to pull implements through the ground, rotational energy through the power takeoff shaft to drive attached machinery, and hydraulic pressure to control and adjust those implements on the move. Modern units range from 20 horsepower compact machines used in vineyards to articulated four-wheel drive units producing over 650 horsepower for heavy tillage work. A fully ballasted four-wheel drive unit can exceed 50,000 pounds, a weight significant enough to cause subsurface soil compaction that stifles root growth for years after a single pass. The current frontier is autonomy. Manufacturers including John Deere and Monarch now produce models that use AI and 360-degree cameras to operate with zero human supervision, increasing field uptime by 30 to 40% through optimized route planning and reduced idle time. The tractor has gone from a basic replacement for animal labor in 1916 to a satellite-guided command center managing every stage of the crop cycle. The moldboard plow. The moldboard plow is a primary tillage tool that inverts the soil 180 degrees, burying surface vegetation and exposing fresh earth below. Its critical engineering development was the transition from cast iron to self-scouring steel, which allowed heavy, sticky soil to slide off the blade rather than clogging the mechanism. This made it possible to work the dense prairie soils of the American Midwest and similar terrain that defeated every lighter tool before it. The trade-off is significant. Total soil inversion destroys established soil structure and leaves the surface exposed to wind and water erosion. It demands more draft power per foot of working width than any other tillage implement. It remains the standard tool for breaking ground that has not been farmed before and for clearing heavy crop residue before replanting. The chisel plow. The chisel plow breaks up soil using heavy-duty shanks without inverting it. Where the moldboard turns the entire soil profile over, the chisel fractures it vertically, relieving compaction while leaving crop residue on the surface. That residue cover is the point. It retains soil moisture, reduces erosion, and preserves the biological structure that inversion destroys. It requires less horsepower per foot of width than an inversion plow, but still demands a capable tractor to pull its deep shanks through hard ground. It offers incomplete weed control compared to inversion methods, and is typically used in rotation with other implements rather than as a standalone solution. For farmers operating under conservation tillage programs, it is the standard first pass. The precision planter. The precision planter places individual seeds at a defined depth and interval, one at a time, using either mechanical or vacuum metering systems. This is called singulation. By ensuring every plant has equal access to light, water, and nutrients, precision planting increases final yields by 10 to 15% compared to older broadcast methods, and reduces seed waste by 5 to 10% by eliminating overseeding and overlap. The John Deere DB120 is the largest production model with a 120-foot toolbar planting 48 rows at 30-inch spacing in a single pass. It requires a tractor producing at least 370 horsepower and 5 hydraulic outlets to manage its vacuum meters and active downforce system, which adjusts 5 times per second to maintain exact seed depth regardless of changes in soil hardness across the field. The air seeder. The air seeder is a high-capacity sowing system for cereal crops like wheat and barley, where high plant populations are required in narrow rows across very large areas. It uses a central hopper and pneumatic blowers to move seed through a network of tubes to individual openers across working widths that can exceed 100 feet. Where the precision planter places individual seeds, the air seeder operates as a controlled, high-volume delivery system, prioritizing scale and speed over individual seed placement. These machines are typically integrated with large carts carrying both seed and fertilizer, allowing simultaneous application of nutrients during planting. They allow farmers to work thousands of acres within the narrow weather windows that cereal planting requires. They are the standard tool across the Great Plains of North America and the broadacre farming regions of Australia. The combine harvester. The combine harvester integrates 3 separate harvest operations into a single continuous pass: reaping the crop, threshing the seed from the stalk, and cleaning debris from the grain. Inside the machine, a high-speed rotor beats material against metal concaves, using centrifugal force to separate seed from plant matter, while large fans blow chaff away, and clean grain is elevated into a holding tank exceeding 400 bushels. The entire operation happens while the machine moves through the field at speed. Modern self-propelled units, like the New Holland CR 1090, have set world records, harvesting approximately 879 short tons of wheat in 8 hours. Current models incorporate predictive ground speed technology that reads satellite yield maps and adjusts machine velocity before entering high-yield areas, preventing internal blockages and maximizing processor throughput. A single operator in a climate-controlled cab replaces the labor of hundreds of people. The forage harvester. The forage harvester cuts and shreds green biomass crops, including corn and alfalfa, into precise lengths of approximately 1/5 of an inch to just over 1 inch for fermented animal feed. Unlike a grain combine, it processes the entire plant rather than separating the seed, using a high-speed cutter head with up to 48 blades to reduce the standing crop to uniform chop. A critical internal component is the kernel cracker, a set of rollers that crushes corn kernels to ensure their starch content is digestible after fermentation. Without it, kernels pass through livestock intact and the nutritional value is lost. The most powerful production model is the Krone BIGX 1180, equipped with an approximately 1,477 cubic inch V12 engine producing 1,156 horsepower. That output is required because green biomass carries significantly more moisture weight than dry grain, producing extreme resistance through the cutter head. The forage harvester is the primary supply machine for the dairy and beef industries, converting standing crops into storable fermented feed within hours. The self-propelled sprayer. The self-propelled sprayer applies crop protection chemicals and liquid nutrients across large areas with precision that ground-driven or aerial alternatives cannot match. Models like the Case IH Patriot 4450 carry 1,600-gallon tanks on boom widths up to 135 feet and use a high-clearance chassis sitting 4 to 5 feet off the ground, allowing the machine to drive through mature crops without physical damage to the canopy. Pulse width modulation nozzles maintain consistent droplet size regardless of vehicle speed, which is critical for preventing chemical drift onto neighboring fields or waterways. AI integrated systems now apply inputs with sub-inch accuracy, reducing total chemical use by up to 60% compared to conventional broadcast application. The sprayer has shifted crop protection from broadacre blanket treatment to targeted precision delivery at industrial scale. The center pivot irrigator. The center pivot irrigator is a self-propelled sprinkling system that rotates around a fixed water source, covering circular fields that can exceed half a mile in diameter. The engineering challenge of the system is that its outer towers must travel significantly faster than its inner towers to maintain a straight lateral line. This is solved by increasing nozzle flow rates progressively from the pivot point outward, delivering more water per unit time as the circumference grows. Modern systems use low-energy precision application drop hoses that place water directly at soil level rather than spraying it into the air, reducing evaporation loss by up to 30%. These machines have converted millions of acres of semi-arid land into productive farmland, producing the circular crop patterns visible in satellite imagery across the American Great Plains, the Middle East, and Central Asia. A single pivot can irrigate over 130 acres in one rotation with no operator input. The Nexet system. The Nexet system abandons the tractor and implement model entirely. It is a single carrier vehicle producing 1,100 horsepower into which the working tool, whether a seeder, sprayer, or harvester module, is inserted as a standardized unit. The machine operates on wide-span tracks that span approximately 46 feet of working width, ensuring 95% of the soil surface is never driven over. This approach, called controlled traffic farming, preserves the natural soil structure across the majority of the field, increasing water infiltration rates and long-term fertility compared to conventional equipment that compresses the ground with every pass. In 2026, the Nexat harvester module set a world record, harvesting approximately 703 short tons of soybeans in 8 hours at a fuel consumption of approximately 0.8 of a gallon per acre. It is the most significant departure from conventional farm mechanization in a century, consolidating every major field operation into one platform, while treating the field itself as a managed system rather than simply a surface to drive on.